So, okay, so the first thing that you're asked to do is to look at a 1 kilohertz 6 volt peak-to-peak signal from your function generator. So first of all, you need to set that on your function generator. So use the coarse knob, just rotate it. There's a bit of a delay from when you turn it to when you actually, it changes on the scale here. When you get in the rough ballpark, start to use the fine frequency adjustment. Okay, so we have a kilohertz being generated by this guy. So then we're asked to have a 6 volt peak to peak. So the way we can measure that is using our vertical scale, knowing that the vertical scale is set to 1 volt per division. So each one of these main divisions on the screen that you see is 1 volt. So 1, 2, 3, 4. You've got a range of around 8 volts on the screen. So what we want to do is have a 6 volt peak to peak signal. So that's from peak to trough, peak to peak. So the way we do that then is we adjust our amplitude on the function generator until we get about 6 volts between peak to peak, like so. Now we also have a Y adjustment knob which can help you position it to make it easier to get that. So you can adjust it with this guy, and you can also with the X position here adjust the X position. Now that's important because you can set up your wave so that you have a reference point to measure from. Okay, so what you need to do then is sketch what you see there and label on there what the period is. So the period, remember this is a time scale. So the period is from peak to peak this way, and the amplitude is going to be half of the peak to peak voltage. So you need to then put that into your equation for a wave, a simplified equation of a wave, which is in your notes, and then try and take this signal that you have here and turn it into an equation. If you have difficulty with that, talk to your demonstrator. Okay, so then I'd just like you to change the function generator, the sine wave out of the function generator again. So change it to half a volt peak to peak and a 5 kilohertz signal. So it's basically just changing the wave again. So let's change it to half volt peak to peak. So we may need to change our vertical scale, and it's ideal to have your wave so that it fits entirely on the screen. It gives you the most accuracy in your scale, so that's probably the best we can do. At the moment, that's set to half a volt per division. So that means each one of these main divisions is half a volt. So we wanted half a volt peak to peak, so we've still got too high an amplitude there. So let's reduce it again. We can change our scale again. So now it's down to 0.1 volt peak to peak, and we can change the amplitude until we have basically, you might need to change the Y position. We want 5 divisions. That will give us 5 times 0.1. And it's a bit of mucking around to do that, but eventually you'll get close to it. Okay, so then we have approximately 1, 2, 3, 4, 5 divisions peak to peak, which is 5 times 0.1 on the scale, 0.5 volts peak to peak. So, and then we're asked to change it to a 5 kilohertz signal. So you can't really sometimes trust what this says here. So that's the idea of the crow, is we're using the crow to calibrate this guy. You can trust the crow. It's a very highly accurate piece of equipment. You cannot always trust what the dial on the front of these LEDs say. So don't just trust that it's 5 kilohertz here. We actually have to measure it here. So let's change the scale here. So you can see that the period there is much shorter. So we've got a much higher frequency there, and that's currently at 9.9 kilohertz. So let's change the frequency down. You can see the distance between the peaks gets longer until we get down to, again, with the fine adjustment, close enough to 5 kilohertz there. So that's a 5 kilohertz signal. So you can change the time division to fit 1 wave on there, or 2. Okay.